Welcome back, Algebra 2 Trig. We are going to continue with more Trig, yay! So, after the benchmark, we are going backwards actually to 6.1 using fundamental identities. The essential question today is, how can I use trig identities to simplify expressions? Now, we've skipped over this part because it wasn't necessary in calculating stuff like double angle, half angle, but in terms of working with trig, it's really important that you see like the connection between different trig functions. Now, we're not going to prove all of these at this point, but what you're going to copy first is this entire box of fundamental trig identities. So that's going to take quite a bit of time. So go ahead and pause your video and take care of that right now. Most of these you are already familiar with, especially these top parts, the reciprocal identities. The quotient identities we also introduced to you, but these three are the ones that are going to be pretty important, so go ahead and focus on these. Include these if you forgot them already. Okay? So after you've copied them down, we're going to go ahead and do an example in which we use these identities in order to rewrite some expressions and make them a little bit simpler. So example 1, I want us to simplify the following expression. So we're going to simplify something that looks like this. Tan of x and then times secant squared of x minus tan x. Okay? So looking at this, it looks really complicated. There's a lot going on. My goal is actually to reduce this entire expression into just one term. So looking at this, I'm going to try to see what I can do. I notice here I have one term. Over here I have another term, and they both have tan x. So I'm going to go ahead and factor that out. And that leaves me on the inside with secant squared x minus 1. At this point, if we don't know any of the identities, this actually doesn't really work out too nicely for us. But we have to refer to the trig identities in the book. And what we know is that secant squared x is equal to, let me get the exact one for you guys. Secant squared x is equal to 1 plus tangent squared x. So right here I'm trying to look, is there any way I could manipulate this identity to somehow reflect what we have here? Luckily this one works out pretty nicely, and I'm going to subtract 1 on both sides. So I get secant squared x minus 1 equals tan squared x. So what I have right here is exactly what I have inside the parentheses. So I'm actually going to replace it and substitute in the value of tan squared x. So now I have tan x on the outside, and I've replaced secant squared x minus 1 with the identity of tan squared x. At this point, because they are both tangent functions, I can go ahead and multiply them together. So this is tangent, kind of like tangent x, just a singular one. This tan squared x is similar to two tangent x's multiplied together. So multiply these two together, and I get tangent cubed x. All right, and that's actually the answer for example 1. So simplifying all of that into this guy using the identity that you guys just copied from the table. All right, so that will take some getting used to and memorization as well. So do get familiar with all of the identities there. Example 2, we're going to go back to factoring using trig identities. The first example, though, is kind of a more simple one. We're just going to factor something that has the same trig identity. And what I mean is that in this problem, I'm going to have 5 sine squared theta minus 6 sine squared theta plus 1. So what I mean by a singular trig, or not squared, sorry. What I mean by singular identity or singular trig function is that I don't have like cosine or tangent, something else lurking in this whole expression. Instead, it's all just sine. For those of you who think factoring this might look a little too confusing, you're used to something like 5x squared, you can do that if it really confuses you. So let's say that sine theta equals x instead. If that helps you in factoring, I can replace both of the sine thetas like this and have 5x squared minus 6x plus 1. So that's one way you could do this, or you could just factor straight up from this guy over here. All right. So factoring just by guess and check, I'm going to have 5 over here, 5 over here, and then sine squared theta, so it's going to be a singular sine theta over here, sine theta over here, and then, actually that's going to be a 1, sorry, because 5 times 1 would be 5, and then the two numbers I'm going to need to make a positive 1, but then a negative 6, I'm going to have negative 1 and negative 1. Okay, so just guess and check. You may use the big X if you need to. You may factor using this way if you needed to, because then this would just come out to 5x minus 1, and then x minus 1. If you went this route, you would then substitute sine theta back in to get this answer, because then this is what we're looking for. Okay, so again, you can factor normally and then just substitute whatever you took back out. Okay. And then finally, example 3, we're going to combine what we did in example 1 and example 2 together into some monster problem. So example 3, we're going to factor one more time. So in this one, we're going to have negative sine squared u minus cosine of u minus 5. So the reason I'm saying that we're combining both is that I have two separate trig functions right here, and I can't really do any factoring because sine of u doesn't become cosine of u. It doesn't work that way around. Instead, I got to find a way to replace one of these. I'm going to go for the sine squared u because I know my trig identity is sine squared u plus cosine squared u is equal to 1. So somehow I want to change this guy into something that involves cosine squared u. So let's try this. Subtract sine squared u, so that way it's going to be negative. And then I get cosine squared u equals 1 minus sine squared u. I still have sine stuck with something else, so I do want to move that 1 away as well. So I'm going to subtract 1, which means cosine squared u minus 1 is equal to negative sine squared u. All right, so what I can do now is substitute all of this guy into negative sine squared u. Alternatively, you could have just solved for sine squared u by subtracting cosine squared u and then substitute it in for sine squared u. Okay, and that means you would have to distribute the negative. But using this way, I don't have to take care of that negative anymore. I just get rid of this entire thing. So I'm going to replace this guy with cosine squared u minus 1. And I'll put that in parentheses just to remind us that we did just put it in. Minus cosine of u minus 5. So at this point, I do need to combine like terms, the negative 1, negative 5. I have cosine squared u minus cosine of u minus 6. From there, I'm going to factor. So I have cosine of u over here, and I have cosine of u over here. I have a negative 6, and I need a negative 1 in the middle, so it's got to be negative 3 plus 2. All right, so that's actually the completely factored form after we had converted one of the trig functions into its separate identity. And that's pretty much how you go about it. All right, so go ahead, rewind, replay as needed. Make sure you look over that trig identity table because there's many ways to manipulate, but some ways are a little bit easier than others. All right, have a good day, you guys.